exciting day. All right, so can't remember if we hit on this at all yesterday. There are these things called positive trig quadrants. Now, we talked about the quadrants themselves, right? But now there's special angles that they're positive in. So let's label these again. This is quadrant 1, and then it goes counterclockwise. So quadrant 2, 3, and 4. We're just going to build a little more each day, because trig can be a lot. It's like learning a new language. So we're just going to go little by little. Okay, so now positive trig quadrants. That's what we're focusing on right now. In quadrant 1, we say they are all positive. So I want you to underline the A in all and say all positive. Okay, now I'm going to give you a little phrase, and you can make up your own phrase or use whatever you want. So I'm going to say all, jot this down, students tip cows. All students tip cows. Now, again, I want you to underline the A in all, the S in students, T in tip, C in cows. Cow tipping is an actual thing. Fun fact, my husband's family grew up on a dairy farm. We have 150 cows. I didn't know that. You can come see us at the fair over the summer showing cows. If you're bored, come to the cow barn or find us there. But all students tip cows. So A goes in the first quadrant for all. We're going to put an S here. What do you think S stands for in trig? Give me a trig word. Did you say sin? My math heart's cracking. Sine. So this is going to stand for sine, and its partner. Whose sine's reciprocal partner? Cosecant. That's who's positive in the second quadrant. So S for sine, and then it brings along its reciprocal. So all students, what's going to go here? T for tip. So who do you think goes in this quadrant? Tangent, and it's going to bring along its partner. Who's its partner? Cotangent. All students tip cows. So who's our main trig function? Cosine. And who's its reciprocal partner? Secant. Excellent. Okay, so this tells us where these trig functions are positive. Now, what do you think happens if tangent tries to sneak into sine's quadrant? Tangent's going to be a what number? Negative. This is the positive sine quadrants. So if I'm in cosine's quadrant and sine tries to sneak in, cosine's positive, but sine is negative. These are the positive trig quadrants.
In the third quadrant, wouldn't it be entirely negative because it's negative in both directions?
Okay. But tangent, well, you draw it, tangent's opposite over adjacent, and the two negatives make a positive. Yep. Okay, so here's how we're going to go. Example 3. All we want to do is figure out what quadrant we're sitting in. So you're always going to draw yourself cute little axes. And Alex, we're going to put in our letters, all students tip cows. And we're going to slowly, one by one, try to eliminate where we are so we know what quadrant we're sitting in. So let's start with this first piece. Sine is a what type of number? Less than is negative, right? Sine is less than 0. Sine is negative. Okay, so A stands for all, meaning they're all positive. So can sine be here? No, because the sine is negative. This is where sine is positive, so can it be here? No, because sine is negative. So that eliminated 2 quadrants. Now let's go to the next one. Secant is positive. Now secant is whose partner? Which original trig function? Cosine. So if secant's positive, so is cosine. So out of these 2, where am I sitting? On the right. I'm in cosine's quadrant. This is where cosine is positive. So I am in quadrant 4. with just one, right? You need two pieces of information. So one will always eliminate two quadrants, and then the next one will narrow it down to exactly where you're sitting. All right, I'm going to make up, here, right up here, let's make another one. Let's say tangent theta is greater than 0, and cosine theta is less than 0. Let's make up our own one real quick. Tangent theta is greater than 0, cosine theta is less than 0. So make yourself the quadrants. Let's label all students tip cows. Okay, if tangent is what type of number? Greater, so it's a positive. Where do I have to be sitting if tangent's positive? Where would I be? I could be in all or tan. So these two are out. Does that make sense?
Wait, how could you be in T?
Because this is where tangent's positive. They're all positive here, and only tangent's positive here. These are the positive trig quadrants. Okay, now what are they telling me about cosine? It's negative. So out of the two that are left, where do I have to be? Why tangent? Why not all? They're all positive, and clearly cosine is negative. So I've got to be in tangent's quadrant. Mm-hmm. Yeah.
Would you, in the bottom half, when the hypotenuse is down, would the hypotenuse like be considered negative?
No, our hypotenuse is always positive. I'll let you think about that. Think about why the hypotenuse should always be positive. All right, let's try number 4 while Dree thinks. Make your quadrants. Label your all students tip cows. Mm-hmm. Yes. All students tip cows. So got number 4. Okay, what's the first thing they tell us, Grady? Meaning that it's a positive. So sine has to be positive. Who can I eliminate? Tangent and cosine. Sine has to be positive, so it's here or here. Okay, now this one's a little trickier. Sine times cosine has to be a what type of number? Negative. Now what do we already know about sine? It's positive. Put a plus sign above that piece. What operation, Alex, am I doing here? Sine what cosine? Times cosine. If I'm multiplying these two together and getting a negative, what does that tell me cosine has to be? Telling me cosine has to be negative. Okay. So I've got to be in quadrant S because they're all positive and we just said cosine is negative. So just a lot of self-talk. All right, example 5. Let's get our picture drawn. All students tip cows. In what two quadrants could this theta lie, if sine is equal to cosine? Name one quadrant where sine and cosine are going to be the same sign, positive or negative. All, right? They're all positive here. So sine could be positive and cosine could be positive in the all quadrant. So I could be in quadrant 1. Now, what if they're both not positive? What if they're both negative? If sine is negative and cosine is negative, where does that have to put you? In T. Because this is where sine is positive, this is where cosine's positive, and they're both negative in tan's quadrant. Does that make sense? Sarah, are you with me? Kind of. If they're both positive, I have to be in the first quadrant. It's the only place they're both going to be positive. If they're both negative, I can't be here because sine is positive, and I can't be here because cosine is positive, but in tangent's quadrant, tangent's the only positive, the other two are both negative, so it makes sense that they're down there. Okay, so that's one way you're going to see it. Second way, they're going to give you a point on the terminal side of theta. So I want you to, again, make yourself an axis. And we're going to, if you see a point, we're going to plot the point. So go ahead and plot, count out tick marks. Plot out -4, -3. And put a point there. -4, -3. What quadrant are you sitting in? Tan, okay, so I'm going to go -4, -3, and I'm going to put my point here, okay? Now, I want you to draw a line from the origin. So we went -4 to the left, and then we went down 3. What shape am I starting to make? A triangle. And then we're going to connect it to make that hypotenuse. Remember, it's always going to look like the bow tie. So I went left 4, down 3, and I'm going to make that bow tie. Now let's put some numbers on it. I went -4. Then I went down 3, so I went -3. What do you think I have to find next? The hypotenuse. You might know it off the top of your head. Don't shout it out. If you don't, what are you going to use if you don't know it? Pythagorean theorem. You got it. This is one of those magic triples that you talked about in geometry, perhaps. And if you don't know it, that's totally okay. Just use Pythagorean theorem. What number do we get? 5. And you get a positive 5, right? Our hypotenuse is always going to be positive. Now, once you draw the picture, this is a really easy question. It wants you to find tangent theta. So let's jot down tangent theta. Okay. Now go back to our first day of trig. Tangent in what words is who over who? O over A. So look at your picture. Who is your opposite? -3. And who's your adjacent? -4. And again, we could label those hypotenuse. Adjacent means next to our angles at the origin, remember? And here's our opposite. Our angles, I should mark my angle. Our angle's always at the origin. No. It depends what quadrant you're in also, right? Hold that thought. Maybe we'll get to an example like that. And what do these two negatives obviously make a positive? Does it make sense? This is tangent's quadrant. Our answer should turn out to be a positive, okay? All right, I want you to try the next diagram. So you're going to make your axes, plot your point, -7, -2, and make it into a nice right triangle. Quadrant did we end up in? 3 again, okay? Get your missing side. Little Pythagorean theorem. Who are we ending up with? The square root of 53? Did you do -7 squared, like in parentheses? No. That might do it. Make sure you always use parentheses. Yeah. Square root of 53 sound good? All right, wants you to write out all 6 trig functions. So take a moment and write out all 6. Start with easy, sine, cosine, tangent, then write its reciprocal partner. All 6 trig functions. for sine? Negative 2 over the square root of 53. Sounds good to me. Opposite over hypotenuse. Now, what can't we leave on the bottom? The square root. So all we do is we multiply the top and bottom by square root of 53. So we should get negative 2 root 53. And any root times itself is just itself, 53. Steph, what do you have for cosine? Square root of 53. Yep. And then when you rationalize that, who do you get? Sorry, is that what you said the first time? Sorry. I was just going step by step, apparently. And tangent. McKenna, who do you have for tangent? Sine, or I guess sine is O over H.
So negative 2 is opposite.
Correct.
So negative 2 over negative 7.
Yes, negative 2 over negative 7. And then we're really just going to call that a 2/7 because those two negatives make a positive. All right, so once I have those, I'm just going to go get the reciprocal. Let me start with cotangent. That's probably the easiest one. Cotangent just becomes 7 over 2. Now, when I flip these bears, so I'm going to look at sine. I'm not going to flip this cleaned up one because it's going to put a radical on the bottom. I'm going to flip the first one because that radical will just move to the top, and I don't have to do extra work. So the reciprocal of sine is called cosecant, and I'm just going to say it's root 53 over negative 2. Does it make sense to flip the first one? Then you don't have to worry about all those radicals. And then cosine becomes secant, so I'm going to say root 53 over negative 7. Okay, so SOHCAHTOA, super important. It obviously trickles into everything we do here. Flip the page. Okay, so now they're going to turn it just a little bit. So they're either going to ask it with a point. Point is super easy. You're plotting the point, or they're going to give you a trig function. All right, so let's make our quadrants. Now, you agree you don't have a point to plot. This is not a coordinate, not a point. You're not plotting a point this time. They're giving you a trig ratio. They don't tell us what quadrant it's in. We got to figure that out. But we know enough information to figure it out. So they're telling us, just look at the positive or negative. Is cosine positive or negative? All right, so let's go. All students tip cows. Cosine is negative. Who am I not in for sure? Not in all positive. Where else am I not? I'm not in C, right? I'm not in positive cosine. Okay, that eliminates those two. Now, out of the two left, they're telling me tangent is a what type of number? Positive. So where do I have to be? Tangent's quadrant. This is where it's positive. So you're going to draw your triangle. You're going to go out, down, and make your right triangle with theta at the origin. Okay, so this is not a point. I had to draw in the triangle based off my quadrants. Now I'm going to go back to what they gave me. In SOHCAHTOA, who was cosine again? Who over who? A over H. So I'm going to go to my picture and label this. Now, the hypotenuse is always what we said? Positive. So this negative goes with the adjacent. Not with both. Two negatives would make a positive. It goes with the adjacent. So my hypotenuse is 5. My adjacent, which is next to the angle, is negative 4. Does it make sense that we're putting a negative here? Because we're going to the left. That should make sense. All right, go get your missing side. Is that a triple we know, hopefully? Okay, but now your picture is going to dictate what that is. Because this is going down, what should I label this side as? Negative 3. Okay, because this is going down, in my picture, I have to slap a negative on it. All right, so let's start with sine. Rowan, who are you going with for sine? Perfect. And I'm going to do its partner right away. The reciprocal of sine is called cosecant. So I'm going to say that's 5 over negative 3. Let's go cosine. Do we already know cosine? Negative 4 over 5, and its reciprocal then is secant, 5 over negative 4. Eli, what are you thinking for tangent? Negative 3 over negative 4, perfect, which is really going to be 3/4. And its reciprocal then cotangent should be 4/3. Let's just talk through the signs one more time. Whose quadrant are we in? Tangent. So here's what you should do at the end. The only answers that should be positive are who? Tangents. Everybody else better have a negative. We are in tangent's quadrant, therefore everybody else should be negative. And it did work out that way, but just double check yourself. Yeah. They would. It's probably going to be multiple. If it's multiple choice, so just make sure you know if it's short answer. Sure, that's fine. All right, letter D. Draw yourself your axes. Okay, so it's not a point. We have to figure out what quadrant we're going to fall into. What do we know? Let's talk about tangent. What do we know about tangent? It's a what type of number? Positive. So I'm going to go all students tip cows. What two quadrants could I be in if tangent's positive? A and T. So who am I going to eliminate? S and C are out. Now they have to tell me one more thing, and they do. I want you to highlight this. It is a positive acute. There it is, acute angle. What does that word acute mean? Under 90. What quadrant's under 90? It's got to be in quadrant 1. Okay, so again, make it look like the bow tie. Go over, go up, and connect. There's my theta. All right, we can label tangent. What two words come to mind when we hear tangent? O over A, TOA. O over A. Label your opposite and your adjacent. Opposite, adjacent means next to the angle. And then go get your missing side. Again, you can use Pythagorean. This happens to be a triple if you know it. That's okay if you don't. Just use Pythagorean theorem. What are we getting for that missing side? 10. 6, 8, 10. 3, 4, 5. 6, 8, 10. And then we're going to write our trig functions down. What should I know about all my answers? Should they all be positive, negative, or a mix? All positive. I'm in quadrant 1 where everybody's positive. Natalie, who are you going with for sine? 6 over 10. And then its reciprocal, cosecant, is just 10 over 6. Morgan, who are you going with for cosine? 8 over 10. It's reciprocal secant. Remember, they go with the opposite letter. The S goes with the C goes with the S. Secant is 10 over 8. And then we already know tangent. They gave it to us is 6 over 8. Therefore, cotangent is 8 over 6. Piece of cake. Are we doing okay? So either going to get a point or you're going to get a ratio, and you got to figure out where it's sitting. All right, one last one. Now they're going back to a point, so this should be really nice. Plot your points. Make your axes and plot your points. Now, if you don't know root 5, what number that is exactly, I mean, A, you could type it in your calculator. If you didn't know B, you do know which direction you're going in. Where are you going? Positive or negative? Positive. So go over a positive distance. What quadrant does that put us in? 4. I'm going over root 5. Okay, and then I'm going down 3. What am I going to put on that down 3, of course? Negative 3. Okay. Not exactly a triple now, so careful with your Pythagorean theorem. Use your Pythagorean theorem to get your hypotenuse. And your hypotenuse is always a what type of number? Positive. Use parentheses when you plug into your formula. square root of 14 sound good to everyone? Okay, can you break 14 down at all? I don't think so. There's no perfect squares in 14. Okay. And then again, label all 6 trig functions. It's got to be the, because it's an angle, right? Theta represents trig, and trig's about angles. You've got to have that theta in there. Every time you write a trig function, you got to have a theta. Rohan, who do you have for sine? That sounds great. And he's got it rationalized. If before that, it should have just been negative 3 over root 14. So I'm going to go get my cosecant. I'm going to base it off this first one. So I'm going to say cosecant is root 14 over negative 3. Perfect.
You always drop the radical when it's on the
Yes, you want to clean that up. Alex, what do you have for cosine? You've got it cleaned up. 14 radical 5 over 14, you said? Are you sure about that? Am I losing my mind? So that's root 5 over 4 square root of 14. Wait a minute. I got root 5 over root 14. So when I rationalize that, I'm going to say that's root 5 times root 14 over 14. Because I'm multiplying by root 14, right? That's how you rationalize.
So there's just 2 square roots on the top.
So you can multiply your square roots together. So that's going to be the square root of... No, that's what we keep saying. You have to rationalize the denominator. You can't leave a root in the denominator. Root 5 over root 14. This is not rationalized. We don't need radicals in the denominator. You multiply by itself. Why do you multiply by itself? Because any root times itself is just that number.
Oh.
That's the whole point of doing it. Root 14 times root 14 just becomes 14. That's why I'm multiplying it by itself. So here I'm going to get root 50 plus 20 is root 70. So I'm just going to get root 70 over 14. Yes, when we did that radical unit, you could multiply the insides together. So I'm going to say root 70 over 14. Then tangent is opposite over adjacent, so I'm going to go negative 3 over root 5. So what am I going to multiply by? Root 5. So I'm going to say negative 3 root 5 over 5. Now when I do cotangent, I'm going to flip the first one I had because that's just going to move this to the top and then I don't have to rationalize. So I'm going to have root 5 over negative 3. What was my cosine? My cosine was root 5 over root 14, so I'm going to get root 14 over root 5. Now who do I have to multiply by? Root 5. Yes, you got it. All right, we've got 10 minutes to get a little practice in here. So you're going to see a mixture of the 3 things we talked about. So the first thing is finding the quadrants. You're going to draw these out and start eliminating who you can be in. Then you're going to be some with a ratio that you'll have to figure out, and then some with points. So I think we got to grab scrap paper. So grab some scrap paper. Well, we got 10 minutes to start. I don't know.